So question 7 is some trigonometric proofs. So looking at A, I mean, the obvious thing to do there is to square out those brackets. So just be really careful. That's not going to be sine squared theta plus cos squared theta. It means multiplying those brackets out. And do be careful that you're using the correct notation. So sine theta times sine theta is sine squared theta, which we always write as that. Okay? So the squared comes after the sine. It's just the known convention. So then I'm going to have plus sine theta cos theta, and then plus another, well, cos theta sine theta, but I'll write it the same way round to make it more obvious. They are like terms, and then plus cos squared theta. So I can see where this is going. So just to be really clear in my proof, I'm going to rearrange it slightly. I'm going to write the sine squared theta and the cos squared theta next to each other. And then I've got plus sine theta cos theta plus another sine theta cos theta. So this is looking hopeful because I wanted 2 sine theta cos theta in my my final answer. And then, I mean, it tells us here to use the identity. You won't be told it, you'll be expected to know it. But if that equals 1, and in fact, I'll use the 3 equals lines because I'm not actually calculating anything here. These are identities. If you use just 2 equals lines, you'd be fine. So sine squared plus cos squared theta is 1, and then 2 sine theta. And then at the end of any proof, just put something to show that you have got there. So as required, QED, proven, anything like that, just to show that you have finished. Okay, so B so we'll look at this one now. So the main things about B is, well, obviously it's got tan x in, so we'll be using this identity. And then also, we're trying to get it written just as a single term. So at some point, we're going to need to be able to add these together. So first thing I'll do is rewrite tan x as sine x over cos x. Again, we're told that there, but you would be expected to know that. This is just that obviously if cos theta is 0, you can't divide by 0. So and then tan theta also, it wouldn't work there. So then I've got 1 over tan x. So that is 1 over sine x over cos x. So that's starting to get quite messy. So if you just think, well, actually, that's just a reciprocal of tan x. So it's going to make it much, much clearer if I just write it like that. And if you were happy just going straight to that second line and not writing that out, that would be absolutely fine. So 1 over tan x is a reciprocal of tan x. Okay, so then, well, I need to add those together. So how do you add fractions together? They need to have the same denominator. The lowest common denominator is going to be sine x multiplied by cos x. So the first fraction, to give it that denominator, needs to be multiplied through by sine x. So this sine x multiplied by another sine x is going to give me sine squared x. And then the second fraction already has sine x in its denominator, so needs to be multiplied through by cos x. So cos x multiplied by another cos x is cos squared x. So now they have the same denominator, so I can just add them. And again, we can start to see that this is going to work out nicely, because sine squared plus cos squared is 1, and that's what I was aiming for. And again, let's just show that we have finished that. So C is looking a little more complicated, but actually it is very clear where to get started for C. We're going to square those brackets out. So I'm going to write the whole thing out just so I don't mess anything up. So 2 sine y minus cos y squared, so times by itself. And do make sure that every single time you're writing it, you're writing sine y, cos y. If anywhere in your proof you just write sine or you write sine x or anything, you're not going to be able to get full marks. Okay, so then the second set of brackets are also expanded. So let's write those out clearly. And what I am hoping is going to happen here is somehow I'm going to get sort of lots of well, I'm going to get sine squared theta plus, sorry, sine squared y plus cos squared y multiplied by 5. That's what I suspect is going to happen. Let's just confirm it. Okay, so there's just a lot of brackets to multiply out, so just be really careful. So I've got 2 sine y times sine y. Again, make sure you use the correct notation. 2 sine y times minus cos y. 2 sine y times minus cos y again. So again, perfectly correct if I'd written minus 2 cos y sine y here. But if I write them the same order, it just makes it much easier when I'm collecting like terms to see what's going on. And then I've got minus cos y times minus cos y. Then I've got my second set of brackets. I'll change colour just to hopefully make it a tiny bit clearer what's what. So I've got sine y times sine y, so that's sine squared y. I've got sine y times cos y. I've got, sorry, sine y times 2 cos y. And then I've got 2 cos y times sine y. So again, I'm just going to write them consistently, write the sine y first, just so it's obvious they're exactly the same thing. And then I've got 2 cos y times 2 cos y. So that's looking quite messy, but if I start to look at what I've got, it simplifies right down, because I've got 2 sine y cos y, I've got minus there, and then plus there. I've got minus 2 sine y cos y, plus 2 sine y cos y. So that's all completely cancelling. I've then got 4 sine squared y plus that sine squared y. So that's 5 sine squared y. I've got that cos squared y plus that 4 cos squared y. So that's 5 cos squared y. So I just want to really clearly show that I've got there. So I'm going to take out a common factor of 5. Okay, and again using sine squared y plus cos squared y is 1. That therefore equals 5. Okay, so last one. So again, obvious way to start on this, I'm going to want to square out those brackets. So it's 2 minus sine A minus cos A sine A minus cos A. So I just want to be really careful about that minus there. So in fact, the way I'm going to do it is I'm going to keep some brackets there and not worry about the minus, so just expand these brackets and then do it at the end. So I've got sine A times sine A. I've got sine A times minus cos A. This time I'm writing the cos first, it really doesn't matter. And then another minus cos A times sine A, and then minus cos A times minus cos A. Okay, so then I think what I'll do is I'll tidy up those brackets first before I worry about that minus. So sine squared A plus cos squared A is 1. And then I've got minus cos A sine A minus another cos A sine A, so minus 2 cos A sine A. Okay, so then I'll do the brackets. So 2 minus 1 is 1, and then 2 minus sine A cos A is 2 plus sine A cos A. Yes, so sorry, I've switched the order again there. It really doesn't matter. Okay, so that's all fully simplified. Now I'm actually going to look at the result for this one and just think about, well, can I convince myself that they are the same thing? So in fact, let's just neaten this up a bit. So in fact, what I'm going to do is take the right-hand side of this one and just double check what happens when I square those brackets out. Okay, so I've got sine A times sine A. I've got sine A times cos A. I've got sine A times cos A again, so just to save a tiny bit of time, I'm going to switch that to a 2, and I've got cos A times cos A, and then sine squared A plus cos squared A is 1, so that is 1 plus 2 sine A cos A. So that's fine. I've convinced myself that they're the same thing. Do just need to be a little bit careful with how I've laid that out. So I think I'm okay, but I'm just going to be really clear that that's what I've got the left-hand side to equal. That's what I've got the right-hand side to equal. And then just write a conclusion that they both equal the same thing. So we have completed the proof.